At what angle should a water gun be aimed in order for the water to land with the greatest horizontal range? So if we think about this, do simple projectile motion along the ground as shown here. If we have the water gun here and we're going to shoot the stream of water, it's going to follow a parabolic path shown here and land here. We want to know at what angle should this be fired for R to be the greatest. So we want to know what theta should be in order for it to be the greatest possible value. Now, you're told that R is equal to v squared sine of 2 theta over g, but I'm going to go over the explanation of where this equation comes from, especially this sine 2 theta that just sort of pops up into the equation in the slides. So to start it off, we're going to deal with the y component of its motion. So we're just going to start off. So y naught, its initial position is 0 meters, and its final position is also 0 meters. And we know that we have an initial velocity in the y direction is equal to v naught sine theta. It's going to last for some time, which is what we're going to try and solve for. And we know that the acceleration is equal to a negative g, which is negative 9.8 meters per second squared. Here I denoted that g is the magnitude, so 9.8, and the negative sign tells us the direction. So this is what we have for that. So if we now use our equation, y equals y naught plus v naught yt minus 1/2 gt squared, and we use this equation to solve for time, we can cancel out this term because it's 0, and we can also cancel out this term because it's 0. Now we have v naught yt minus 1/2 gt squared is equal to 0. Now we add 1/2 gt squared to both sides. Now we can cancel the t, and if we multiply by 2 and divide by g, we get time is equal to 2 v naught y over g, which is 2 v naught sine theta over g. Now, if we deal with the x component of its motion, we know that x is our range that we want. X naught is equal to 0 meters. We know v naught x is equal to v naught cos theta. We know ax is equal to 0. And then time is what we're going to plug in for here. So we know the time is 2 v naught sine theta over g. Because this is the time for the object to go from its initial position of y naught is equal to 0 to its final position of y is equal to 0. This is the entire time in which the object is traveling. So this also accounts for the entire time that the object is traveling in the x direction. So that's why we put t is equal to 2 v naught sine theta over g into the x equation. So if we do that now, we have x is equal to x naught plus v naught xt plus 1/2 axt squared. We can cancel this term because we know ax is 0, and we can cancel this term because we know x naught is 0. So we're left with x is equal to v naught xt. If we now plug in what we know, we would get r is equal to v naught cos theta times 2 v naught sine theta over g. If we now multiply this out, we get r is equal to v naught squared 2 sine theta cos theta over g. So this is where you got to in the slides, and then you immediately jump to showing that that equation is also equal to this. But in order to explain this a little more, we know there are things called trig identities, and one of them is that the sine of 2 theta is equal to 2 sine theta cos theta. So what you simply are doing is plugging in sine 2 theta where you see 2 sine theta cos theta in this equation, which gives us r is equal to v naught squared sine of 2 theta over g. This gives us the range that we want based off of theta, an initial velocity, and the acceleration due to gravity. Now you want to maximize this equation, so we find the greatest r. So we want to make sine of 2 theta as great as possible, because v naught squared is and g are constant. They're not changing. So we want to know when we can make this the greatest possible value of the sine. So we know sine ranges between 0 and 1. So we want to know at what angle will make our value equal to 1. Now in order to get this direction, this trajectory, we're limited to any angle between 0 degrees and 90 degrees as shown here. So we're between 0 and 90 when we have to fire this. So we want to know when we can get this to equal 1. So sine of 2 theta is equal to 1. Now we do I'm going to do the inverse sine, so 2 theta is equal to the sine inverse of 1, which we know that sine of 90 will give us 1, so this is 90 degrees here. If we now divide by 2, we find that theta is equal to 45 degrees. So in order to achieve the greatest horizontal range possible, you have to fire your water gun at an angle of 45 degrees in order to achieve the greatest possible horizontal range. So the answer for this question is C, 45 degrees.